So interpretation is process stability, process capability. Please one more time type PS and PC in the chat box. Very, very important. Okay. Whenever process is stable, stability does not mean capability. That is something that's a big takeaway that you need to understand from the session today. Okay. Stability does not mean capability. Okay. So process stability, you should look for patterns of variation. It should be random and not systematic pattern. That is where we'll go to the depth of different types of patterns. Okay. You should look for the presence of special causes, and I will share with you the 8 rules of special cause. All of you type 8R in the chat box. Let me share with you the 8 rules. Okay. I'll share with you the 8 rules now. I've already explained the capability and stability with a blood pressure example, so I'm not explaining you further. Okay. So now the question is, what type of variation affects every result and is chronic in nature? Special cause, common cause, a random cause, or where isolated incident. I'm just asking a random question at this point in time. What is your answer? Let's see in the chat box. Yes, B is the right answer, because chronic means, just all of you can correct your answers if you're not able to. I've given the explanation. I'll share this slide also. Common cause means it is chronic, many in number, appears quite frequently. Okay. So I just wanted to. Okay. Another question, random question is, which of the following is most likely an example of special cause of variation? Slight fluctuations in daily output, one-time machine failure causing spike in defects, seasonal variation in customer demand, long drift in a measurement system. Okay, let's see. Just a quick test on special cause and common cause for you. All right, I'll settle down with time machine failure that causes spike in defects. This is special cause because one time it happens, okay? Okay, now the summary of this, okay? Now, these are you can take a screenshot of this, okay? How do you identify the patterns? So there are 8 points, okay? You can take a screenshot of this, okay? 1 point more than the standard deviation from the center line, 9 points in a row, 6 points in a row, increasing, decreasing, 14 points in a row, alternating up and down, 2 out of 3 points greater than 2 standard deviations, 4 out of 5 points greater than 1 standard deviation, 15 points in a row at 1. Don't remember all this, okay? I'll give you this presentation. You don't have to remember, Ayyo, what is this? This guy is boring with so many things. How do I remember? Don't worry. Software will tell you the pattern. AI itself will identify a pattern and tell you whether there is a special causes present or not. But then for you to understand, how do you look at in the control chart? If you see rule number 1, 1 point is more than the 3 standard deviations. Because standard deviation is something that you can calculate and plot. And if there is 1 point which is more than standard deviation, then it is a special cause of variation. We need to identify and eliminate the special cause. If rule 1 is clear, type R1C in the chat box. So rule 1 is clear. I'm going to go through all these rules very quickly. It's just simple common sense. You just have to know these rules. You need not have to remember these rules. I'm telling you, you just have to know these rules. Second, 9 or more points in a row on the same side of the center. If you see here, the center is here, okay, which is X double bar. But if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 points in the center, that is also an indication of a special cause. How do you say that? Don't worry. Mathematicians have established that it is not possible statistically for 9 consecutive points to be on one side of the center. Okay. And if it is so, there is some special cause in that. If rule 2 is clear, type R2C in the chat box. R2CC. R2 crystal clear in the chat box. Rule 2 is clear. Great. Okay. Let me go to rule 3 now, because I need to cover all the 6 rules, right? Now, 6 or more points in a row, steadily increasing or decreasing, irrespective of the center. Okay, if you see here 1, 2, 3, 4, 5, 6 increasing points, so that is an indication of special cause. So we need to identify and eliminate the special cause. If rule 3 is clear, all of you type R3-CC in the chat box. Rule 3 is crystal clear. Excellent. Okay. Rule 4. Rule 4 is a very interesting rule which most of the people may not know. Okay, 14 points alternating up and down. You might think it is a normal variation. Okay, it is likely to be up and down. But 14 consecutive points up, down, up, down, up, down means somebody is tweaking the process, increasing. Again, it goes this way, decreasing. Again, it goes this way, increasing. So that's also a cause of a special cause. If rule 4 is clear, all of you type R4-CC in the chat box. Okay, we need to identify such special causes and eliminate them. This is a rule 4. Now, rule 5. 2 out of 3 consecutive points greater than 2 sigma from the center line. Okay, so you need to draw a line on 1 sigma, 2 sigma, and 3 sigma. Okay, and then you need to see, 2 points here are greater than 2 sigma. That means there is a special cause. How are these rules set? Please trust me, all the mathematicians have spent so many years of life to really give us on a platter that all we need to do is just understand that there is a special cause and go ahead and find them. Our job is to find out the special cause. Here, the data is showing this, and the software will tell you that there is a special cause. Okay, our job is to go and find out. If rule 5 is clear, all of you type R5-CC in the chat box. And rule 6 is 4 out of 5 points, 5 consecutive points greater than 1 sigma. So this is 1 sigma here. You find here 1, 2, 3, 4, 5. Okay, more than 1 sigma. So that is also a special cause. Okay, just like 2 sigma, there's 1 sigma limit. But here, instead of 2, 4 out of 5 consecutive points. So type R6-CC in the chat box. If R6 is clear, we need to identify also such special causes in these cases as well. Okay, rule number 7 is 15 points in a row. I'm sorry, there's a spelling mistake. 15 points in a row within 1 sigma of the center line. Okay, within 1 sigma. This is 1 sigma. 15 points in the row is within 1 sigma, which is not possible, statistically not possible, and hence there is something wrong happening. There is a special cause. We need to identify and eliminate them. Please type R7-CC in the chat box if rule 7 is clear. Okay, I'm little rushing this because these are all available all over the internet. So it is just for me to show this first to you so that when you go and explore yourself, you know, okay, these are some rules to identify. And a run of 8 consecutive points greater than 1 sigma from the center line on either side. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, up and down on this. That is also an indication of this thing. So R8CC is, so with that, I've covered all the rules. You just have to remember the rules. Don't worry about how it is done. Okay, you just have to collect data and find out these patterns. And you need not even find out the pattern. Now, this slide is the most important slide. That's why I rushed through other things. Common causes, systemic and chronic variation affects every result. It can be large or small, and the causes may be known or unknown, whereas special causes is sporadic or assignable cause, we call it. It affects the result either a one time in a temporary way, a one time in a permanent way, and it can be large or small. Causes may be known or unknown. Now, the point that I'm going to give here is, this is a very interesting slide. Now, for the type of action that you'll have to take for special cause and common cause. Okay. Now, if it is a common cause, okay, what is that we need to do? We need to make basic changes in the process. If it is special cause, we need to take action based on the reported difference, because special cause will affect the data significantly. One data will be here, other data will be on the corner. That's why it's gone out of control limit. So I want to show this interesting data. If it is a common cause, do not look for what was difference between individual points. You'll be wasting time. If this is clear, type crystal clear, CC in the chat box. If it is common cause, do not look at difference between 2 points and see why there is a difference between two consecutive points. You'll be wasting time. Okay, this is something that's very, very important for you to understand. Okay, and if it is common causes, do not take action based on that reported difference between 2 points. You will increase variation. People who don't understand this, just take notes, just take screenshots. It's okay if you don't understand this, but this is a very precious slide. If you take actions based on two different points, you will increase variation. If this is super clear, type yes, C in the chat box. Super clear in the chat box for those who find it clear. If it's not clear for somebody, don't worry. Just hang on and take screenshots of this. That's enough. Okay. Suppose if it is special cause and you're studying all the data, then you lose time responding to the problem. You'll be wasting your time. You're losing time to responding to the problem. If this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. If it is a special cause, do not study all the data. At the same time, if you are a special cause, do not make changes to the process. There'll be loss of productivity. It might increase variations. Again, if you're clear about this, give me a 9 or 10 if it is crystal clear. So in summary, for common cause, you should study all the data actually and make changes to the process. If it is a special cause, you should look for difference between 2 points and take action based on the reported difference. So common cause means please study all the data. You will gain a better understanding of the system and please make changes to the process. It will reduce variation. If it is a special cause, you please look for difference between the 2 points and take action based on the reported difference, and it is reduce the variation. Okay, so if this slide, if you found it interesting, useful, valuable, fantastic, awesome, put it in the chat box because people who can comprehend this really appreciate this slide. All right, thank you very much. And let's get into one question. What is a key characteristic of the special cause of variation that differentiated from the common cause of variation? Occurs regularly, predictably, originates from within the system design, affects every outcome, often one time or sudden occurrence. Now you'll be clear, right, how to answer this question. All right, so you got the right answer. Special causes variations are typically temporary sudden events. Super. Which of the following is not a feature of common cause variations? Affects every result, can be large or small, always has known cause, systemic and chronic. Not a feature of common cause, okay? Which is not a feature of common cause. Okay. Which statement is true about both common and special cause of variation? Both are always present. Both are always have known causes. Both can be large and small in magnitude. Both affect only one output. Yeah, both are small in magnitude. Yeah. Awesome. All right. So the presence, just to conclude here, okay. The presence of one or more points beyond either control limit is a primary evidence, okay, and a special cause of variation. Therefore, any point beyond a control limit is a signal for analysis of operation of the special cause. So, mark any data points that are beyond control limits for investigation and corrective action based on what special cause actually started, okay? So a point outside a control limit is generally a sign of one or more of the following. Maybe the control limit or the plot is miscalculated. Sometimes it might also happen that you don't calculate the control limit properly, or there is a piece-to-piece variability, or the distribution is increased, or the measurement system has changed. Please watchful of that. And measurement system also, maybe it lacks discrimination. You can also check that. And a point below the lower control limit, these are all some pointers I want to give you. The control limit or plot maybe is in error. Okay, sometimes you wrongly calculate the control limit, or spread of distribution has decreased or become better, and also the measurement system. Okay,